Hey guys, it's Kyle from Siftree. You might think it's a good idea to use LLMs to extract topics from text or documents, but I'm here to tell you that's actually a very bad idea. And if you're doing anything in this capacity that is being displayed towards customers, you need a much more fundamentally sound approach because LLMs are not good. So why do we do topic analysis in general? Say you have a bunch of support tickets or customer reviews and you're trying to extract themes from inside all these reviews, and it could be thousands. You can't read them all. So you might think, hey, let's just pass this to an LLM and it'll extract the dominant themes of what's inside. We do this to find things like key aspects of complaints, maybe even feature requests. Maybe you're, identifying a competitor that people are switching to. There's a lot of different reasons why you might want to extract certain themes from a large body of text. So with an LLM, you might think, hey, like, let's just pass it a prompt, we'll feed it all these documents, and then we're good to go. But we have to think about what is an LLM actually doing when you prompt it to get topics. So, like for example, I have this book here. This is a pretty big book in the data warehousing or data modeling space, and you might think, okay, so I'm going to give this book to an LLM. It's going to read through the pages. It's going to write down what it sees. It's going to keep going. It's going to come back and look at the things that it generated, maybe do a little bit of aggregation of, okay, I'm noticing the word star schema, or I'm noticing like dimensional modeling, and then it's giving you like this list of themes that it has extracted by going back and forth between the book and what it's writing down. And that's not what it's doing at all. I mean, you have to think about in how these LLMs are trained, right? It essentially has an idea of what a topic is. So in its pre-training, it has seen humans summarize text. It's seen humans summarize and extract topics from other things, or it's been trained on actual topic modeling algorithms, and it's trying to, it has an understanding of what a topic typically looks like. And it's doing that, it's thinking about and predicting what does a topic typically look like, and it's applying that to the tokens that it sees in this document. So there is no back and forth. It's like trying to predict what does a topic typically look like, or what does a topic output typically look like based on what I've been trained on, and how can I apply what a topic typically looks like to this corpus, to this document that you have presented to me. There's no real math going on. There's like nothing actually happening. Now, there is a little bit of frequency that is implicitly carried over through attention. So, say the word, I don't know, Salesforce is mentioned a lot in the document. In those tokens, if there's a lot of these tokens that look the same because they all say Salesforce, in the attention mechanism process, that there is a frequency that but it's implicit. Like it's not an explicit frequency that you can actually see and audit. So there is a little bit that is going on, but it's nothing that you can actually audit or actually understand yourself. So you rerun the process, you redo it, you're probably just going to get completely different answers. Again, there's no reason why, and there's no explanation for it. So what should you do? What should you do instead? You should actually run a real topic modeling or clustering algorithm on top of this document. So the difference is this algorithm has no understanding of what a topic is. It has no pre-training. What it's doing instead is it's converting your document into embeddings. If you're not familiar with embeddings, it's just vectors that represent the semantics. And then it's just going to be doing an actual like density algorithm on top. It's going to be looking at how frequent things pop up and how tightly compact all of these mentions of certain phrases or certain words are within the document. In that way, we're looking at the entirety of the document. We have no issues with like context windows. We have no sort of like lossy middle area. I don't know if LLMs actually kind of like humans are really good at the beginning, really good at the end, a little bit fuzzy in the middle when they're reading something. Um, we don't have that problem when we use these clustering algorithms. It's taking the entire corpus as its whole. And what's great about this is now we have real explainable metrics. We understand how dense a cluster is. We understand how many documents actually support this cluster. We actually understand how tight the center is, and maybe there's a lot of documents kind of like on this outer shell. We have an understanding of the distances, within the clusters and actually between clusters. There's just a lot of proof. And if we're doing anything that is going to be presented to a customer, we need this proof because we have to iterate. We have to improve the model over time. We have to understand why things are good, why things aren't good with the current approach, because we're going to get feedback. Nothing's perfect. And you actually have to be able to understand where are things breaking down. What can I actually tweak? What are the parameters that I can tune to create a model that explains the data in a way that actually makes sense, not only geometrically, but in a much more valuable way to our customers. And if you're using these LLMs, you have no control. You're feeding it a prompt, you're telling to it extract topics. Again, it has an idea of what a topic is. It's trying to understand what an idea of a topic is to the tokens that you've passed to it. Um, and there's no explanation for why it does what it does. But a real clustering algorithm, you have all this type of control. So LLMs, great if you're trying to get a scan or like a first pass of what's in the data. It's plausible. The results are plausible, but they're not defensible. And if you're doing anything that is customer facing or you're like going to make real decisions on, you need defensible, you need auditable, you need something that you can actually understand the outputs, and it's not just a black box that said, yeah, here's what we're finding. Another thing that's interesting too is, because they're trained on topics, outputs, or summarizations, they have an idea too of how many topics there should be, right? It might give you 10 to 20 because that's what it thinks, the LLM thinks, like how many topics I should be explaining. But what if there's thousands? If you're feeding it a document, like, let's say millions of PDFs, and you ask it to extract the themes, it might only give you like 10 to 20, and like okay, like, oh, I'll just use the new Opus 4.7, and maybe give me a couple hundred, high reasoning. Again, though, it's just thinking about how what does it know, and it's trying to guess what it should produce, as opposed to just taking a pure mathematical approach. One is plausible, the other one's defensible, and quick pass or exploration, LLM's fine. Anything that's going to be presented to customers or you're making decisions off of, you need a real clustering approach. You need a real algorithm that's going to take this without bias, just explain what's in the data objectively. So yeah, LLMs sound great in theory, not in practice for any real high stakes decision making.